Problem 16 in the OPENSTAX Chapter 3, we've got a problem C here. We need to convert 0.25 pounds of this herbicide Treflan into moles of compound and then moles of each type of atom. And we've got several atoms here: carbon, hydrogen, nitrogen, oxygen, and fluorine. And they also give us pounds, and they give us some information here. Okay? So the first step we need to do is find out how many moles of this substance we have. In order to do that, we need to first calculate the molar mass, or the formula weight, of this substance. And we do that by taking each element, finding its subscript, and multiplying by the average atomic mass that you find in your periodic table. I like to use the average atomic masses from ptable.com as a source of my weights. So we have 13 carbons, we have 16 hydrogens, okay, we have 2 nitrogens, we have 4 oxygens, and we have 1 fluorine, and we just have one of those, so that's 18.998. Okay. Now we have to add all of these masses up from each of the different types of elements, and we're going to get the net or total weight or formula weight of this substance. Okay, so I'm getting 283.279 grams per mole. I'm going to write it like this: grams over 1 mole. And we're done with the periodic table now. So first, I want to calculate the moles of the compound. And we basically need to convert grams to moles. But before I do that, I have to convert pounds to grams. So we'll set that up as follows: 2.5 pounds and 454 grams over 1 mole. 1 pound. Okay, so the pounds cancels. Now I have grams. Now to convert from grams to moles, I use the formula weight. Now I can write this like this or flip it around. I'm going to have to flip that around so that I'll be left with 1 mole of the substance, and the grams will cancel. Okay. So grams cancels, and I'll be left with moles of the substance. So on our calculator, we could punch this all in. And we want to round this off to 2 sig figs because our starting value here has only 2 sig figs. And so here we would want to write the whole formula out: C13, H16, N2O4F. Okay? Okay. Now to convert that to moles of atoms, we need to copy the formula down. C13, H, double check that that's right, 13, 16, 204F. All right, and we have 0.5 0.40 moles of this substance, okay? And so what we want to do on this whole page is convert moles to moles. So let's do carbon first. In the formula, we know that there's 13 moles of carbon per 1 mole of the compound, C13, H16, N2O4F2. I'm just going to call this the compound. Okay, so I'm going to abbreviate this CMPD from now on so we don't have to write it so much. So the way you set this up is you write down the moles of your compound. Okay, set up your fraction bar, and then on either side of this fraction bar you want to position 1 mole of your compound, or 13 moles of carbon. We want 1 mole of the compound to be on the bottom of the fraction to cancel, and we want 13 moles of carbon to be on top because those are the units we're going to be left with. And we get 5.2 moles of carbon. So we're done with carbon. Hydrogen, we know there are 16 moles of hydrogen per 1 mole of the compound. So we set it up in a similar way. We take the starting quantity of our compound in moles, and we position the two different parts on our conversion factor. We want 16 moles of hydrogen to be on top so that the 1 mole of compound on the bottom cancels. So 0.4 times 16 is going to be 6.4 moles of hydrogen. Okay, we should box up each one of these. These are going to be many different answers for this problem. Next, we want to do nitrogen. Nitrogen has 2 moles of nitrogen per 1 mole of the compound because the subscript is 2 for the nitrogen. So we again set it up we position the 2 moles of nitrogen on top, 1 mole of compound on the bottom. So that's just going to be 0.80. Okay. Be sure you have that 0 there. We must have 2 significant figures. Oxygen, we have 4 of those. I am getting a little bit ahead of myself here. Mislabeled the units. This should be moles of compound that we're starting with once again. And we have 4 moles of oxygen because the subscript is a 4 for the oxygen. So 4 times 4 is 16, right? So that's going to be 1.6 moles of oxygen. Okay. And the formula, there is not a 1 written there. I just added a 1 here. Not sure if you saw that. But there's a 1 right after the fluorine, which means that there's the same number of moles of fluorine as there are compounds. So there's no real math to do here. We could just do it in our head. They're equivalent. So it's going to be 0.40 moles of fluorine because the subscript is 1. So there's no math to do for that one. All right. So those are all the answers for this question here, 0.25 pounds of the herbicide Treflan. So thanks for watching, and please subscribe.